Hello and welcome to the first episode of Old World Botany. In this series we'll talk about the history and science of different fruit, vegetables, and general botanical states of affairs that occurred in the Old World in both the past and the present ages. In this episode we'll cover a paper by Larissa Garkava Gustafsson. Within Finland, the apple is one of the most important fruit crops within that region. It is the fourth most important crop within Finland and Sweden. The Swedish and Finnish apples are on the northern edge of the apple's hardiness zone. It's also quite humid, making it more suitable for plant diseases to take off, making it difficult to grow apples in that region. Apples were introduced in the 12th century from Central and Southern Europe, and were grown mainly as monastery orchards. Commercial apple production began in the 16th century, and relied almost entirely on foreign cultivars, although there's still some local cultivars still being selected and grown during that time period. In the 1920s, Sweden began breeding their own cultivars, oftentimes using local cultivars as parents, to develop new varieties adept to the northern climate of Sweden. Since the plant breeders were often looking for new sources of genetic variation, these researchers, led by Larissa Garkava Gustafsson, began trying to parse out the genetic diversity within Swedish apples, utilizing 43 Swedish cultivars, 42 Finnish cultivars, and 16 Central European and British cultivars. The DNA was extracted using different chemical methods such as the Quagen-Denesi kit, PCR amplifications, and the megabase DNA sequencer. Using this information, the researchers made estimates of the genetic diversity and tried to figure out what genetic groups each population belongs in, and here are the results of their experiment. For the study of SSR polymorphisms, which is one indicator of genetic diversity, a high degree of polymorphism was found within the various cultivars of apple utilized. 105 unique alleles were found in the entire set of 101 cultivars. The expected heterozygosity was somewhere between 0.31 and 0.39. In terms of heterozygosity, another measure of genetic diversity. The observed heterozygosity was, however, much higher, ranging from 0.41 to 0.88, depending on the group, indicating that there's a high level of genetic diversity and a low level of inbreeding within these populations. The amount of genetic diversity within, it was also found that the populations could be blocked into 3 genetic groups. The levels of genetic diversity between groups was not statistically significant. In essence, all genetic groups are quite diverse in genetics. In terms of heterozygosity, the lowest value was found in Swedish cultivars, but the highest value was found in European cultivars, with Finland being somewhere in between. In terms of unique alleles, the Swedish cultivars had the highest level of unique alleles within a population, while European cultivars had the lowest, with Finland again being somewhere in between. Another thing that was found was that, although Swedish and Finnish varieties are genetically separated to a certain degree, there's still intermixing between the two groups. 5 Swedish groups have a great deal of Finnish ancestry within it, while 5 Finnish cultivars have varying proportions of European and Swedish ancestry within their pedigree as well. As mentioned before, the apples could be subdivided into 3 subpopulations. Group 1 consisted almost entirely of Swedish cultivars, 29 in total, followed by 8 Finnish cultivars and 3 European cultivars that likely had a great deal of Swedish ancestry within the pedigree of these apples. The Group 2 population had 26 Finnish cultivars, 4 Swedish cultivars, and no European cultivars. Group 3 consisted of 13 out of the 16 European cultivars. The genetic data also suggests something else. Within the genetic groups, 94% of the genetic variation happens within groups, and 6% of the genetic variation found within these cultivars occurs between the groups. So as per usual within cultivated plants, most of the variation occurs between individuals of a group rather than between groups. The researchers also drew a conclusion that there is a small level of lower genetic diversity within the Swedish and Finnish germplasm collections in comparison with European cultivars. Another factor was, although they could differentiate different groups, when it comes to genetics, each population is intermixed with something else. This makes sense considering that since the introduction of apples in the 12th century, new introductions from foreign countries have continued to appear. This would have allowed for more and more variation to show up, and allowed for more intermixing between different populations. Most of these populations carried almost no European pedigree, and the Finnish, Russian, and Swedish cultivars are more close to each other than they are to European varieties. This may indicate a common genetic background for the Eastern European countries' apple varieties. And it makes sense since these three countries share similar climates. The Finnish cultivars that are grouped closely to Swedish and European origin, discussed within the paper, were compared with another paper studying old Russian cultivars, which showcased that those Finnish cultivars that were located more southern had more in common with Western European genetics than Russian or common Swede genetics. This indicates that at least some of the Finnish cultivars of apple have more pedigree within Western European countries than in Eastern European countries. A small subpopulation of Finnish apples seem to have close genetic ties, in fact, to Spain. In conclusion, the Swedish germplasm is still quite genetically diverse and can be utilized for future uses in Swedish breeding programs. And that about covers everything. Thank you for watching this video. If you're watching on YouTube, please subscribe to me on BitChute for a greater variety of content, 4 videos a week. And thank you to all my subscribers on both platforms. I appreciate it.